Good afternoon, everyone. Are you able to hear me?
Yes, sir.
Okay. Fine. I'll just revise once again so that things are clear to you. We were discussing about risk. We, we came across that there are two types of risk. One is systematic risk and second is unsystematic risk. Systematic risk, everyone has to face it. Unsystematic risk can be managed within the company through proper management. Systematic risk is the risk that everyone is going to face, and you cannot reduce this, you cannot make this risk zero. The only thing that you can do is you can only reduce the intensity of that particular risk. Now, if you want to reduce the intensity of that particular risk, we should be able to fix a value to that particular risk. So only when we fix a value to that particular risk, only then we can reduce it or increase it. To assign a value to that particular risk, the two major uh, measures that we use are standard deviation and beta. Standard deviation measures the overall variation of that particular risk, and beta indicates the sensitivity of that particular stock or sensitivity in terms of risk. So these are the two major calculations that we are going to understand. We come to standard deviation. In standard deviation, there are two parts. First part is a historical standard deviation, wherein you have the past data and you want to estimate the deviation for the standard for that particular historical data. The formula that you use is in the numerator, in the denominator you put n minus 1, and in the numerator you do not include the probability value. The thing that you can see on the screen, okay, is a formula for the estimation of deviation for the future, right? So whenever we are estimating for the future, there is no n number of observations because it is in future, so there is no n, or there is no denominator. On the other hand, we use the probability. So these are the two important aspects that we have to understand as far as deviation is concerned. I repeat once again, for historical deviation there is no probability, and in the new denominator we have n minus 1. For the probability distribution, or for the probability of estimating standard deviation for future, there is always a probability and there is no denominator, that is there is no n minus 1. So these two things you have to keep in mind. Now going forward, we will try to understand what are the different, how do we measure deviations, right? I think the formula is clearly known to you. The formula that you can see on the screen is a formula that you have to use whenever you are estimating variance or standard deviation for the future. Okay, we'll see a couple of problems now for us to make ourselves comfortable as far as deviation calculations are concerned, and then we'll go to the next part. Now there is an example here. Okay, there is an example here. Kindly go through this particular example so that we can solve this particular example here itself, and we can attain the solution for this particular problem also. Kindly go through this particular table and the example. Quickly go through this. Have you gone through this?
Yes, sir.
Yes, sir.
Now in this particular problem, you can see that I'll just read it out. There is a stock which has given the following returns in the last 6 years. What type of deviation are you estimating? They have asked you to compute mean return and variance. Okay, what type of variance is it? Is it historical variance that you have to estimate, or is it the futuristic variance that you have to estimate? What is it?
Future.
Historical.
Future.
What type of variance you have to estimate? Futuristic or the historical?
Historical, sir.
It is historical. The reason is, see, understand one thing. Last 6 years, the word last 6 years clearly tells you that it is a historical data that has been given to us, and there are no probability values. Can you see any probability values here? Are there any probability values been given to you?
No, sir.
So when there is no probability value, it means this data is pertaining to the last years, and we have to estimate the deviation for the last 6 years, whatever was been experienced. So I'll quickly go through this. These are the returns that the company has given in the last 6 years. Okay, it has given 15%, 12%, 20%. Then it gave a negative return of 10%. Okay, so on and so forth. The returns have been given for the last 6 years. The task is we have to find out the mean and the mean return and the deviation in this particular problem. So how do you find the mean? How do you understand the mean? You just add all these values
Divided by number of days.
divided by the number of observations. Can you do that?
It's 10, sir.
Yeah, please do it. See if you can do it. Just add 15 plus 20, 15 plus 12 plus 20 minus 10. Keep on adding it and then divide it by the number of observations.
It's 10, sir.
Okay, so what is your R? What is your mean return?
10.
So your R basically is 10, right? Sorry. Constant shaking here. Yeah. What is your R? Mean return
10.
is equal to 10, right? Okay.
Yes,
How do
sir.
you calculate deviation? How do you calculate the deviation?
15 by 10, sir.
Not 15 by 10. 15 minus 10.
By, yes, sir.
15 minus 10. What's your answer? 5. Right? Next, 12 minus 10. What's your answer?
2.
Minus
20.
2, right? Next, 20 minus 10. Sorry. 20 minus 10. What's your answer? 10, right? Next answer, minus 10 minus 10. What's your answer?
minus 20.
Minus 20. Next, 14 minus 10. What's your answer?
4.
4. Next, 9
4.
minus 10. What's your answer?
Minus 1.
Minus 1. Okay, now this is these values that you get 5, 2, 10, minus 20, plus 4, minus 1. You get either positive values or you get negative values, but I want all the values to be positive. So if I want all the values to be positive, what I need to do? I have to do square of it. Square of deviation. So if I do square of it, what do I get? Sorry, what do I get? 25, 4, 100,
25.
400, 16,
400.
1. Right? Now add these values. Add these values. Are you able to get 546?
546, sir.
Right? So your total sum is coming to 546 here.
Yes, sir.
Your answer is coming 546. So what is this? This is square of deviation. divided by number of observations. How many observations do you have? How many observations do you have?
6. 6.
So how do you calculate standard deviation? Standard deviation is equal to sum of square of deviations, sum of square of deviations divided by number of observations minus 1. This is what you have been studied, right? This is what you have studied.
Yes, sir.
Yes,
What
sir.
what is your answer in that case?
546
It's 546
divided by 6 minus 1.
divided by 6 minus 1 is 5
109.2.
divided by n minus 1. What is n minus 1?
5.
Comes to 5. So what is your deviation now?
6 minus 1.
Yeah. What's the answer?
109.2.
How much? 1 not
109.2, sir.
0.2. What is this?
9.2.
What is this? Whatever you have told me just now, Rohin, what is this?
Standard deviation
Standard deviation.
values.
Standard deviation? It is not standard deviation. This is variance. What you have calculated right now is variance. You have to do to get
Square root of.
standard deviation. What do you need to do?
So square root of that.
You have to find out the square root of that. So standard deviation is equal to square root of 109.2. Find out. See what is the answer that you get. Is it around somewhere around 10.5?
Yes, sir.
This is somewhere around 10.5.
So 10.44.
10.44, right? So that right? So your answer, what is your answer right now? 10.5?
Yes, sir.
Yes, sir.
So your standard
Yes, sir.
deviation is
10.449 it is.
10.5, right? What does it mean? It means that on an
Yes,
average,
sir.
my return from the investment is 10%, but somewhere I can experience that my return can go up to 20% also, because I have to add 10 to this. I have to add 10 to this. So somewhere my return will go up to 20%, and somewhere my return will come 0 also, because 10 minus 10 is 0, right? This 10 and this 10 and this 10. If you add it, you can expect the highest value, that is you can expect around 20.5% as return, or you can expect completely 0 return. So that is what it talks about standard deviation. So this is a mean return. From this mean value, how much high can I expect, how much low can I expect? That is the meaning of deviation. I think Veergowda sir might have told you this. What is the use of deviation? Or only it was told to you to calculate deviation? Are you able to get the answer here?
Yes, sir.
What happened? You're not able to follow it, or what is it?
Yes, sir. Understanding, sir.
You're understanding? Okay, now please understand. This problem was basically about historical data, wherein in the denominator you had n minus 1. Okay, now we'll go to the next problem. Read the next problem very, very clearly, and then you'll be able to answer this. we have two companies. Given data belongs to two firms with their probable returns. Now, what do you mean by the word probable?
Probability.
It is for the future. I can expect
Future value.
see for company A and company B, there are two companies. The probabilities have been given to us and the expected return are also given to us. Here also the same condition and the same data is available. Okay. Now I can expect 6% return with 10% probability. I can expect 7% return with 25% probability. I can expect 8% return with 30% probability. Okay, 9% with 25% probability and 10% return with 10% probability. So these are probabilities. Okay, when is this return going to come? Probably next year, probably 2 years down the line. So here n is not clearly given. Are you able to understand? N is not clearly given to us. So when n is not given to us, we need to understand that this problem is based on probability calculations. Now if probability is there, how do we need to solve this? Again, I'll just recall this particular formula. Now we are going to make use of this particular formula to find out the mean return, okay, or mean expected return and the expected deviation from this particular company A. This is what we are going to find out. Are you able to get this logic here? I am going to solve only for company A. I am leaving company
Yes, sir.
B for you for your calculations. Is that clear?
Yes, sir.
Okay. Now let us come to how do we find out a solution for company A. Okay. Now we'll try to find out the solution. Okay. I'll just note down these returns here. Now remember, for your simplicity's sake, I will just copy this formula here so that you'll be able to understand what we are doing. I'm just keeping this formula for your understanding. Now we have probability and we have the expected return. That means this could be the return. Now what we need to do first is we have to find out a calculation wherein we have to multiply whatever returns are there with the expected probabilities. That is the first thing that we have to do. Okay, I think I've just missed out on that. I'll just insert one slide here, one column here. Just give me a second. Now what I need to do, I have to multiply probability into the return. I have to multiply probability into return. So if I multiply probability into return, what will I get? 0.10 into 6. What will I get? Will I get 0.6?
Yes, sir.
Okay, next. If I multiply 0.25 into 7, what will I get?
1.75.
1.75. Next. 2.4.
2.4.
Next.
2.25.
2.25. Okay, next.
1.
1.
1.
0.00. That is 1. Are you able to understand this? What I am doing? I have multiplied the probability, what is given to us, and what is the return that is being given to us. I have just multiplied this and I have kept it as it is. Any doubts up to this particular point?
No, sir.
No, sir.
Sure?
Yes, sir.
Yes, sir.
Just give me a second. I'll adjust the columns here. Okay. Now, what I need to do? So these are my probable returns. Understand? I am using the word probable returns. This particular column 3, talks about my probable returns. So what are my total? What is my probable return, expected return, total? Just add this. See, what do you get? See, I'll just tell you one thing. Here, what did you do? You added it and divided by the number of observations, right? Please pay
Yes,
attention to
sir.
this particular slide. In this particular slide of the last problem, you added the returns and divided it by the number of observations. Clear? Here, do you have number of observations? These
No,
are not
sir.
observations. These are probability values. Don't confuse
Probabilities.
probability values with number of observations. Okay?
So they'll mention it clearly, right?
Yes,
The
that means
probability values.
you have to just take the sum of it. Okay, even if you take mean of it, is also fine. So I'll just write down here mean exp expected return. Mean expected return is equal to, how will I calculate it? I'll take the sum of this. Okay,
8.
just add 0.6.
8.
8, sir.
8. Okay,
Yes, sir.
and for if you are getting confused, always put the denominator as 1 to find out the mean return. So 8 divided by 1 is how much? Still 8, right?
Yes, sir.
Best thing is, always remember one thing. I'll make your life simple. Whenever probability is given, you don't have to calculate mean. You have to only calculate the sum. That's it. That's more than sufficient.
Yes, sir.
Sum of expected returns. So your answer here is going to be 8.00.
8.
Clear?
Yes, sir.
Yes, sir.
Okay. Now, what you need to do? You have to calculate R minus expected return. So now, whatever you have got this answer as 8, okay, this is your expected return. So whatever you have got here, okay, this is your expected return is 8. So which means this value is 8 now for you. Now, okay, and this R that you can see, this is your this particular R,
Returns.
whatever is it, right? Now you have to subtract those particular values from this particular from 8. Okay, now how do you go about it, or how do you understand this particular calculations? How will you do it?
Sir, R is 6 or 0.60.
You can take it 6, no problem.
Yes, sir.
You can take 6, no issues. Okay, so now this is your return, right? This is your return 6.
Yes,
So
sir.
now I have to subtract. Okay, is equal to 6 minus 8 is how much?
Minus 2.
Minus 2.
Minus 2. Next, 7 minus 8 is equal to how much?
Minus 1.
Minus 1. Next,
0.
sorry. 8 minus 8 is equal to how much? 0. Next, 9 minus 8 is equal to 1. Next, 10 minus 8 is equal to 2. Clear? So I have got my this particular column is minus 2, minus 1, 0, plus 1, plus 2. These are the answers that I have got for this, right? Okay. What did I find out? Can you see this particular box here? Can you see this particular box within this particular box?
Yes, sir.
Yes, sir.
So we have just calculated that. Now what we have to do? We will have to square it, because there is a square here, right?
Yes, sir.
There is a square here, so we have to square it. So what is square of minus 2? 4.
4.
4.
Square of 1 is 1.
1.
Square of 0 is 0. 1 and 4. True? Are you done with this?
Yes,
Yes,
sir.
sir.
Okay. Now, what is the change here? We have to multiply probability. Can you see this bracket now? Entire thing.
Yes, sir.
So we have to multiply P to this. Okay, so if you multiply probability, what will you get? You multiply 0.10 into
0.4.
4. What will you get?
0.4.
0.4, right?
sir.
This is what you're going to get?
Yes, sir.
Yeah. Multiply the same thing for all the values. So you'll get, I'll just directly write down
0.25.
So you'll get 0.4. Next, what will you get?
0.25.
0.25. Next,
0.
not 0.0 only. Next, you get again 0.25.
2.5.
Next, you get
0.2.
0.40.
0.2.
Is this what you get?
Yes, sir.
Yes, sir.
Now take the sum of this. Why we need to take the sum of this? Because there is summation here. Can you see this here? Can you see this summation in the formula?
Yes, sir.
So you take the sum of this. Is it coming to 1.3?
1.3.
So 1.30 is the answer. What answer is this? This entire answer. Please pay attention. This entire answer is 1.3. That means what have you done? What have you calculated right now?
Variance, sir.
You have calculated, just a minute. So you have calculated the variance. So variance is equal to 1.30 is what you have done. Can you calculate standard deviation? Can you calculate standard deviation? Standard deviation is going to be square root
Square.
1.14.
of 1.30. How much is it?
1.14.
1.14. That is your answer. So let's go back to the problem. What they have asked: given data belongs to two firms with their probable returns, find out the expected risk. Okay, and return. Now question is, you may ask me, what is expected risk? Risk is nothing but standard deviation is nothing but risk. So 1.4 that you have calculated, this is nothing but this is a risk that is associated with that particular company A, and this is the return that is associated with that particular company. So I can earn 8% by taking a risk of around 1.14. Is it a good deal? It is a very good deal because your risk return ratio is very high. Okay, if you divide risk return ratio 1.14 divided by 8, if you do it, you will get a very high risk return ratio. That means it is a good investment proposal. Okay, I have solved this for company A. I want you to solve this for company B. Is that okay?
Yes, sir.
Yes, sir.
So that's SD is 1.69. 1.3 into 1.3,
Why 1.
not 1.14.
Square root.
Yes, sir.
When
Square
you
root
are
only,
doing,
sir.
you
1.
have to get square root. How can square root be more than the variance? Square root is always less than the variance, right?
So it's correct, sir.
Sir, yes, sir. Correct, sir.
Done?
Yes, sir.
Okay. Now, what I'm trying to tell you about this, that standard deviation is one of the critical measures to estimate the risk measurement calculations. The next measurement that we have is we have a intercept called as alpha. So this is another value. Okay, can you see these three graphs here? Okay, they talk about two things. They talk about alpha value, which is mentioned here, and they talk about beta value, which is also mentioned here. Now, what is beta? We'll come to it. Beta is nothing but it. Sorry. Beta is nothing but it is a tool which is used, okay, to estimate how sensitive is your stock to the overall market. When we talk about overall market, we are comparing your stock with the index. Compared to the index, how strong is your share? Is your share very strong, or is your share very weak? We can also interpret as, is your share moving along with the index, or is your share moving away from the index, right? So if we have to estimate this, there is a parameter called as beta calculations. So we have to estimate the beta calculations for this particular segment, or for this particular calculation. Okay, today I will just explain to you what is beta and other things. We'll not go into the calculation part of it. In my next class we will start with the calculation part of it. Is that okay? Now, when we come to the concept of beta, beta indicates how sensitive is your stock compared to the market. A higher beta means that your stock is very, very sensitive, and a lower beta means that your stock is less sensitive. Always remember why these calculations are important. Whenever market is going up, it is always better to have shares which have higher beta value. I'll tell you the reason. Suppose the share that I have belongs to a company called as Havells India Limited. You know Havells, it manufactures electric fans, tube lights and other things. So I have a company called as Havells India Limited. They are into electrical consumer electronics. Okay, and since they are into consumer electrical and electronic equipments, I estimate that there is going to be a good demand for that particular company. Based on that, I purchase shares of Havells India Limited. And I come to a conclusion through my calculation that the beta value of this particular company is 2.1. Okay. Now, what does it indicate? It indicates that if the market goes up by 10%, my stock of Havells India will go up by 20%, double of it, 2 times, right? Because your beta is 2. By whatever amount the market grows, you have to multiply that beta value to the market. That is the expected growth in your company. Say for example, if I have my beta value, somebody is responding. Okay. If my beta value is less than, if my beta value is 0.5, what does it indicate? If the market goes up by 10%, my stock will just increase by 5%. So beta indicates the sensitivity of your stock. Are you able to understand? It is very important that whenever we are in a bull run, whenever the markets are going up, we always need to have shares which have high beta value, because if the market grows up by 5%, your share will grow more than 5%. That should be your calculation. On the other hand, when the markets are falling, you should have shares in your account which have less than 1 beta. The beta of it has to be less than 1. Suppose I have a share of a company called ICICI Bank. Its beta value is only 0.4. What does it mean? It means that if market falls down by 10%, my share of ICICI Bank will fall by just 4%. So whenever your markets are falling down, it is always recommended that you need to have shares of such companies wherein the beta value is less than 1. In a market where you are in a bull run, that means when the market is going up, you always need to have shares in your account which has beta more than 1. When markets are moving in a very stable proportion, it is always better we have shares in our account wherein the beta is close to 1, say somewhere around 0.9, 0.8, 0.9, 1.1, 1.2, that is fine. Okay, so this is the range wherein we can say that your shares are moving in tandem with the market. Okay, and when it comes to portfolio management, or when it comes to all these mutual fund companies, how do they manage your funds? Is basically because they take into account the beta calculation part of it, and they come to know that which segment is good, doing well, so they invest your money into that particular segment. That segment goes well. Okay, when they feel it has grown, they withdraw the money and keep the profits with themselves and distribute the profits to you at a later stage. So this is how beta calculations are very important for our calculation part of it. I will actually help you to understand how to estimate beta using a, I mean, by using a book and a calculator also, and also we will do the same using a Excel sheet. Okay. So what I will do is I will stop here as of now, and in my next class we will continue from where we have stopped. Next class I am going to start with beta calculations. Is that clear? Okay. One more thing, we have just 3 minutes left, less than 3 minutes. All of you, please switch on your video mode. I want to just take the attendance quickly. I want to take the attendance. Switch on to your video mode. Yeah. Fine. So we'll stop the class here. I am going to conduct a mentoring session soon after this particular class. So those who are under me, please join in at 3:30. Not 3:30. It's already 4.
Sir,
Yeah.
so the project mentors which are appointed that,
No, as of now, only my mentor, those who are under me, as of now, only that. Okay. We'll see how to go about it for the other students.
because I am in Veer Gowda sir's mentor group.
Then you join. Don't worry.
Okay.
Okay. Yeah. Thank you.